Welcome to our deep dive on mastering memory management and AI agents. Today, we're exploring dynamic memory allocation to enhance your AI system's performance and resource efficiency. Welcome to our video on mastering memory management and AI agents. Did you know that inefficient memory handling can cripple AI performance, leading to slower processing and higher costs? Today, we'll unlock the secrets of dynamic memory allocation, a game changer for optimizing resource use in AI systems. By the end of this video, you'll have the skills to implement memory strategies that enhance model efficiency, prevent memory leaks, and leverage best practices for optimal AI performance. Let's dive into the essentials of memory management and transform how your AI models operate. In the realm of AI, memory management is the process of controlling and coordinating computer memory, assigning blocks to various tasks, and optimizing resource use. It's the backbone of efficient AI model performance. Let's dive into the fundamental differences between static and dynamic memory allocation. Static memory allocation involves fixed memory size during compile time, while dynamic allocation adjusts memory size during runtime, providing flexibility. This flexibility is crucial for AI agents that process varying data loads. Efficient memory management ensures that your AI models run smoothly, without unnecessary delays or crashes. By understanding and implementing effective memory management, you're setting the stage for superior AI performance. Let's delve deeper into the comparison between static and dynamic memory allocation. Static memory allocation is set at compile time, offering predictability but at the cost of flexibility. It's ideal for applications with consistent memory needs. Conversely, dynamic memory allocation occurs at runtime, allowing the AI agent to adapt to varying data loads. This flexibility is key in environments where data size and processing needs fluctuate, common in AI applications. However, dynamic allocation requires careful management to avoid memory leaks. Understanding when to use each type can significantly impact your AI model's performance and efficiency. Choose wisely based on your system's requirements. Garbage collection is a form of automatic memory management that reclaims memory occupied by objects no longer in use. In AI, efficient garbage collection can significantly enhance system performance by freeing up memory space. There are various techniques, such as reference counting and mark and sweep algorithms, each with its pros and cons. Automatic garbage collection simplifies the process, reducing the chance of memory leaks, but it may introduce performance overhead. Manual garbage collection, though more complex, allows fine-tuned control. Understanding these techniques and implementing best practices ensures your AI models run efficiently, with optimal memory usage and reduced risk of memory-related issues.
Memory leaks occur when a program fails to release memory that is no longer needed, leading to degraded performance and system crashes. In AI systems, where large datasets are processed, preventing memory leaks is critical. To identify potential leaks, monitor memory usage patterns and look for unexplained increases over time. Implement techniques like proper memory deallocation and use of smart pointers in languages like C++. Tools such as Valgrind and Leak Sanitizer can detect leaks, offering insights into their sources. Regular memory audits help maintain optimal performance, ensuring your AI models run smoothly without being bogged down by inefficient memory use.
Memory plays a pivotal role in AI model performance. Adequate memory ensures that your models process data swiftly, without bottlenecks. Efficient memory management not only improves speed but also outcomes, allowing models to handle more complex tasks. Balancing memory with processing power is crucial. Too little memory can slow down processing, while excess memory can unnecessarily increase costs. Memory also affects scalability. As AI models grow, their memory needs expand. Designing memory-efficient AI models involves optimizing data structures and algorithms for minimal memory usage. By prioritizing memory management, you're ensuring your AI systems perform at their best.
Monitoring memory usage is crucial for maintaining AI system health. It helps identify inefficiencies and potential leaks, ensuring optimal performance. Several tools are available for this purpose. Tools like TensorFlow Profiler and PyTorch's Autograd Profiler provide insights into memory usage patterns, helping identify bottlenecks. These tools allow you to visualize memory consumption, making it easier to pinpoint areas for improvement. By interpreting the data from these tools, you can make informed decisions to enhance AI performance, ensuring that resources are used efficiently. Stay ahead of potential issues by regularly monitoring memory usage and adjusting strategies as needed.
Real-world case studies offer valuable insights into successful memory management strategies. Let's explore how leading AI companies address memory challenges. For instance, Google's use of TensorFlow involves sophisticated memory management techniques to handle massive datasets efficiently. By implementing dynamic memory allocation and garbage collection, they optimize resource use and improve model performance. Another example is Facebook's PyTorch framework, which employs memory monitoring tools to prevent leaks and enhance scalability. These strategies have led to significant improvements in AI outcomes, offering lessons for your projects. By learning from these case studies, you can apply proven methods to your own AI systems, ensuring success. To optimize memory in AI systems, adopt best practices that balance resource use and performance. Start by choosing the right memory allocation method: dynamic for flexibility or static for predictability. Use memory profiling tools to identify bottlenecks and adjust strategies accordingly. Avoid common pitfalls like unnecessary data duplication and improper memory deallocation. Leverage tools like memory debuggers and profilers to continuously refine your approach, ensuring efficient resource use. Remember, memory optimization is an ongoing process. Stay informed about new techniques and tools to keep your AI systems running smoothly. These best practices lay the foundation for enhanced AI performance and scalability.
As we conclude, remember that mastering memory management in AI is key to unlocking your model's full potential. By understanding dynamic memory allocation, preventing leaks, and leveraging monitoring tools, you're equipped to enhance performance and resource use. Embrace these strategies, and watch as your AI systems achieve greater efficiency and impact. Don't forget to like, comment, and share your thoughts on this video. Let us know which memory management techniques you're excited to try, and suggest topics for future videos. Your engagement helps us create more valuable content for you. Thanks for watching.